Alright guys, here is your Unit 3 test review. Unit 3 triangle congruence. We did a lot this unit. We did triangle congruence statements with proof, side, 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 side angle, side angle, side angle, 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 side, and hypotenuse leg. CPCTC, corresponding parts of congruent triangles are congruent. We had triangle theorems, triangle sum theorem, exterior angle theorem, hinge theorem, inequality theorem, mid-segment theorem, the circumcenter, and the end-center. It's a lot. We did a lot. So you're going to have to freshen up on, especially the stuff we did in the beginning, if you want to be successful on this test. Alright, so let's look. Number 1, determine if there's enough information in each statement below to allow someone to create a triangle congruent to XYZ. XYZ. So we want this triangle and this triangle only. Can we create this exact triangle using what they gave me here? Triangle ABC is a right triangle. Okay, so let's try this. A right triangle. I can draw a right triangle. There you go. With one angle measuring 30 degrees. 30. And one side measuring 12. 12. Did I just create that triangle? Did I do exactly what they just said here? Yes. They didn't tell me where to put the 30 degrees. They didn't tell me where to put the 12. They just said one angle measuring 30 degrees. I have one angle measuring 30. One side measuring 12. I have that. So I created the exact triangle they did here. But was this the only triangle that I could make? No. Yes, my 30 is in the same spot, but my 12 is here on the hypotenuse. They have a 24. So A is not an answer choice. What about this? Does this mean that it's that triangle and only that triangle? Well, I have this angle here matches that angle. This angle matches that angle. And this side matches that side. So then by angle, angle, side, B is an answer choice. C, triangle ABC is a triangle with side lengths AB. AB is 12 root 3. So triangle ABC, XYZ. So AB must match XY. XY. Is XY 12 root 3? BC must match YZ. Are those true? Corresponding parts are not congruent. On a grid, here's a clue. Hint, 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 anytime it's on a grid. On a grid. Yes. Yes. And more yes. On a grid. Yes, my allergies are acting up, guys, so you're going to have to suffer through this video with me sniffling. Get over it. Anytime on a grid is an answer choice. On any of these tests, your EOC, yes. We can use the distance formula. We can graph it. This is geometry in the Cartesian plane, which means geometry on a grid. So, of course, we can do it on a grid. Complete each statement listed below. Rigid motions preserve side lengths and angle measures. Dilations preserve angle measures but not side lengths. Not side lengths. In this class, we never change an angle. Never change an angle. You ever see an answer choice that's talking about an angle measure changing? Nope. Never happens. Classify by its sides and angles. Sides. This is your equilateral. Isosceles and scaling. Angle measures. This is acute, right, and obtuse. To get this done, those are three angles in a triangle. If I added all three angles in a triangle, they should equal 180 degrees. That's the triangle sum. So 6x plus 6x minus 90 plus 3x plus 30 equals 180 degrees. Combine like terms. There's 6, 12, 15 x's. Negative 90 plus 30 would give me a negative 60 equals 180. Add 60 and you get 15x equals 240. 15 goes into 240. I don't know, nor do I feel like doing the math. 16. X equals 16. So now we got to figure out all my angle measures. 6 times 16. This is 96. So right now it's obtuse because it's bigger than 90. Then you have 96 minus 90. This is 6. And then 3 times 16 plus 30 is 78. Since they're all different, that is scaling. If they were all 60, it'd be equilateral. If two of them were equal, that would be isosceles. Fill in all corresponding parts. Go back here. BA, ED. I don't even have to look at the pictures. I'm not even going to look at the pictures. AC is DF and CB is FE. Angle BAC would be EDF. ACB DFE and CBA would be FED. Using rigid, this means congruent, transformations. ABC has been transformed to XYZ. Choose the statement that can be used in a proof to show that ABC is congruent to XYZ. Rigid transformations, we said it. Where do we say it? Right here. We're going to use this to answer this, where it says rigid motions preserve side lengths and angle measures. That means sides and answer choice. Side angle, sides and answer choice. Angle, side angle, angle, side. All of the above, because rigid transformations preserve both. What's the one you're looking for that's not true? Or not true. Choose all the statements that accurately describe triangle GEO. Alright. Draw your right triangles. By doing this, I'm finding slope and distance. Slope and distance. Slope is rise over run, which will tell me if they are perpendicular, which means 90 degrees. This is 1, 2, 3, 4, so that's 4. 1, 2, 3, 3. So the slope of this line, rise over run, it's going up, so it's 4/3. 4/3. This one is 1, 2, 3, 1, 2, 3, 4. So this is 4, 3. This line is going down, so its slope is -3/4. These two slopes are opposite reciprocals. So GE is perpendicular to OE. So it's a right triangle, guaranteed, because it's perpendicular. Perpendicular means 90 degrees. Equilateral? No, because that's 90. Isosceles? Maybe. Is this the same as that? If you remember from back in the beginning of the year, we can do Pythagorean theorem to find this. This is a 3, 4, hopefully somebody said it, 5. Because we can do a squared plus b squared to find this length. And you're going to get 3 squared plus 4 squared, which is 9 squared, not squared, plus 16. 25 equals c squared, so c equals the square root of 25, which is 5. If I did the a squared plus b squared equals c squared Pythagorean theorem right here, I'm plugging in the same two numbers. It doesn't matter where you plug them in, a and b. I'm plugging in the same two numbers, so I'm going to get the same answer. So this is an isosceles triangle. It's right isosceles. So this is 45 degrees. This is 45 degrees. GE is congruent. GE is congruent to OE. We just found that out. Yes. GEGO. Nope, it's not equilateral. Angle G is congruent to angle E. G and E, nope. G and O. G is congruent to O. So it's a right triangle because my slopes were opposite reciprocals. That's unit 1. It's isosceles because this leg is congruent to that leg. I used Pythagorean theorem to figure that out, creating my right triangle. Unit 1. Because it's isosceles, there's my two congruent sides, there's my two congruent angles. That's unit 3. The fact that an isosceles triangle has two congruent sides and two congruent angles. Alright, L is the midpoint of AB. Okay, so that means this is congruent to that. N is the midpoint of BC. N is the midpoint, so this is congruent to that. M is the midpoint of AC, where AB equals 30. AB, this whole thing, is 30. These are all mid-segments, these in here, because they're the midpoints. So if AB is 30, that means this is, hopefully someone said it, 15. BC is 28. Half of 28 is somebody? Anybody? You're right, 14. And AC is 18, which means this is 9. Find the perimeter, perimeter. Add up all the sides of parallelogram LMNB. Where is LMNB? LMNB. I need to find the perimeter of that, which is going to be, if that's 15, this is 15. If that's 14, this is 14. So 15 plus 15, which is 30. 14 plus 14, which is 28. 30 and 28 is 58. good stuff. Find the lengths of the two sides of a triangle. Select all possible integer lengths to the third side. Okay, third side. Add them and then subtract them. 7 and 15 is 22. So x must be smaller than 22 but larger than 8. Anything in between cannot equal. So that's a no. That's a no. Cannot equal. Yes, 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 no, and no. Must be in between. Must be in between. All of these are in between. Cannot equal. Okay, I'm close to done. This was just like the review we did in class. Find the circumcenter. Okay, it is a right triangle, which means it's the midpoint of the hypotenuse. So here's J. K is at 0, 6. L is at 7, 0. Here is my triangle. From 0 to 6, halfway is 3. From 1 or 0 to 7, halfway is 3.5. So that means the midpoint is going to be here. Circumcenter. The circumcenter is at 3.5, comma 3. Choose all rigid. Rigid. Congruent. Stretch? No. Translation? Rotation. Compress? No. Dilation? No. Reflection? Yes. We don't even talk about stretch and compress. There's no reason why you should ever choose an answer that we have not talked about. An incomplete geometry proof, there we go, is shown below. Complete the paragraph proof with the appropriate reasons. Given triangle TRI is inscribed in a circle centered at R. RT and RI are radii. So this is a radius. Goes from the center to the outside. So is that. So that means they're congruent, which means this is an isosceles triangle. So this angle has to equal that angle. Okay, I know that. I don't even know if that's in the proof, but I know that. Because that's the radius, that's the radius. Two sides are congruent, isosceles triangle. Oh look, prove that angle T is congruent to angle I. I just did that because it's isosceles. So here we go. Given triangle TRI is inscribed in the circle with the center R, and RT and RI are radii. Radii is plural for radius. From the definition of a radius, RT is congruent to RI. Then triangle TRI is isosceles using the definition. It's not a right triangle. It's not the inscribed angle theorem. Property of congruent sides doesn't exist. Hopefully if you have any questions, you're texting me. Remind. Text me through Remind if you have any questions. Here we go. There's my Remind if you're not already attached. You need to be attached. Almost done. Little break. Took a little break, little breather. Answer some text messages. Text me right now if you're annoyed by how much I'm sniffling. Just kidding, don't, because I don't care. Triangle XYZ is isosceles. XYZ. ZY and ZX are the legs. I'm going to do this in a color. ZY. So this is congruent to this. ZY is congruent to ZX. Triangle QRP is drawn inside triangle XYZ such that, different color, QR is congruent to QP. So that's isosceles as well. So I'm going to go ahead and say that this angle is congruent to that angle. Isosceles. And this angle is congruent to that angle because it's isosceles. The big triangle is isosceles. The little green triangle is isosceles. If Q is the midpoint of YX, so this is congruent to that. And YRP, oh jeez, I don't have any more colors. YRP, this one is congruent to that one. How is triangle QYR, how is this triangle congruent to that triangle? And you can see it. This is congruent to that. So there's actually two, because you have angle, side. Oop, there's a backwards ass. Non-answer. Angle, side. They're not right triangles. No, you don't have side. And you don't have side, angle, side. Do you have angle, side, angle? Nope. Angle, side is all you got. I can go angle, side this way or angle, side that way. Doesn't really matter. But side, angle, side, I don't have the angle in between the two sides. Side, I don't have all three. Angle, side, I don't have the side in between the two angles. The only thing I have is angle, side. Okay, complete each statement. The circumcenter is created by the, I'm going to abbreviate, perpendicular bisectors. And is the same distance away from all the vertices. The incenter is created by the angle bisectors. And is the same distance away from all the sides of the triangle. Proofs. LM is congruent to NO. LM is congruent to NO. Given. I have another given. Guess what? It's this. Angle M is congruent to angle O. Right here, that's congruent to that. So MPL is congruent to angle OPN. How? They're vertical angles. And now that's a triangle congruent. So triangle LMP is congruent to triangle. First one doesn't matter, second one must match. NOP. And this one, two givens, so let's LP bisects MO, and then LO is parallel to MP. ON is congruent to MO, MN, ON, this is congruent to that because of this. Definition of bisector. They're parallel, that's what this means. Alternate interior would be those angles. Angle O is congruent to angle M. Alternate interior angles. Vertical angles, right there. I'm going to say ONL is congruent to MNP. Triangle congruence, first one does not matter, so LON is congruent to triangle PMN. And that's it. I want to give you one more with your circumcenter and incenter. I don't want you to get stuck on this. The word problem. If you're talking about being the same distance away from points, that is your circumcenter, created by your perpendicular bisectors. If you're talking about being the same distance away from sides, that's the incenter, created by the angle bisectors. So you plan on meeting at a point that is equal distance from each of your homes. Those are points, circumcenter or perpendicular bisectors. You're putting a trash can in between three rides. When you look at a park map, the rides are going to be points, not sides, which means you're the same distance away from 3 points. So that again is going to be circumcenter. If I wanted to put it the same distance away from these 3, those are points. Okay? So I'm going to find the circumcenter. Installing a countertop, and he wants to put the stove in the in-center. I mean, it says it right there what you're using. Easy access from all sides. Okay, that's the in-center, created by the angle bisectors. Roads. You want to open a store that's equal distance from each road. Roads are the sides. In-center, created by the angle bisectors. Right? Questions, text me. Black day, your test is Thursday. Gold day, your test is Friday. Fifth period, your test is Thursday and Friday. Let me know if you have any questions, guys.